This week's experiment is the separation of a mixture by distillation. You will obtain 24 milliliters of a 50-50 mixture of ethyl acetate and toluene and set up either a fractional distillation apparatus or a simple distillation apparatus based on your hood assignment. To see what a fractional distillation apparatus looks like, let's take a look. So here is a fractional distillation apparatus. It consists of a heating mantle connected to a controller, a 50 ml round bottom that's connected to a fractionating column. You'll notice that the fractionating column has copper wire stuffed inside of it. Then there's a distillation head, followed by a thermometer and thermometer adapter. Please be very careful with the thermometer, as it is very easy to break when putting it through the rubber hole in the thermometer adapter. Next piece is a water jacketed condenser. This is the column piece that does not have anything stuffed in the center of it. You'll notice that there is a water in at the bottom and a water out at the top. And the ports should always be pointed towards the back of your hood. The water jacketed condenser is connected to the distillation head using a Chem clamp so it does not fall during assembly and break. We have a 90-degree elbow at the end of the water jacketed condenser that's also connected by a Chem clamp. Below is your graduated cylinder that is supported on a wire ring by a wire mesh. You'll also notice here that everything is elevated and off the table for two reasons. One, during a distillation you may need to remove the heating mantle from the bottom. Also, before you can attach the heating mantle to the round bottom flask, you must put a little bit of sand in the bottom so that it doesn't stick to the heating mantle. A simple distillation apparatus is set up slightly differently. Here, in the overall picture, you'll see it is much shorter, and that's because it lacks a fractionating column. You will want to have your heating mantle supported on a wire ring, your 50 ml round bottom flask, and here you can see sand going all the way around the heating mantle to give the round bottom flask a uniform heating. Then we have the distillation head, thermometer and thermometer adapter, and as we branch off we still use a Chem clamp to hold the water jacketed condenser. Again, water in from the bottom and out to the sink at the top. Finally, there's a 90-degree elbow and a graduated cylinder that you'll use to collect your fractions as the experiment progresses. The graduated cylinder is supported by a wire mesh on a ring. Rings are available in drawer 178, and the wire mesh is available in drawer 188. When you come into lab, you will have to set up these apparatus. Examples will be left in the lab for you to look at. But please take some time before lab to look at the setups before you attend so you know what the connectivity is. All the pieces for the setups can be found in your microware kits in your hood, in your drawers. They will not be underneath your hood. You can also get additional clamps if they are not already in your hood in drawer 179. Please note, regardless of the setup you are doing, the round bottom flask must be connected with a ring clamp, as you can see here and here. You must support the fractionating column with another clamp, since this will become extremely top heavy. And you should have a clamp on the center of the water jacketed condenser. You notice in the setup in lab that I'm short and only using 2 instead of 3 ring stands. Because of that, I have supported the water jacketed condenser at the 90-degree elbow. It is very important that you do not plug the 90-degree elbow, as that can cause issues during your experiment. Finally, placement of the thermometer is important. To get accurate readings in this experiment, the bottom of the thermometer must be slightly below the elbow, right here, of the condenser adapter. Please make sure that you have the thermometer in the appropriate spot, so as you collect each milliliter, you can record the temperature.